To solve the equation cosine theta is equal to negative square root of 3 over 2 means we need to find the angle or angles where cosine would be negative square root of 3 over 2. You could rewrite the equation in inverse form. I would first want to consider the sine. So in this case, we're trying to find cosine of an angle where the value is negative. So we need to find the quadrants where cosine is negative. Cosine is negative in quadrants 2 and quadrants 3, and that's because those are the two quadrants where x is negative. And cosine is defined as adjacent over hypotenuse, or x over r. So the adjacent side needs to be square root of 3, the hypotenuse side needs to be 2. The hypotenuse is always positive, so that means the negative goes on the square root of 3, and that also makes sense considering where the x values are. So that's a negative in the x direction, and so the square root of 3 should be negative. I mean, at this point you can complete the triangle. So if we have a negative, or if we have a square root of 3 and then a 2 for hypotenuse, you could use the Pythagorean theorem, or the fact that this is one of the special triangles. The other side, the opposite side, needs to be a 1. For this problem, I'm going to draw an example of the special triangles for the 1 square root of 3, 2 triangle. I've got the right triangle written in angle form and radian form. And from these special triangles, that means when we have a right triangle with the values 1, 2, and square root of 3, the 90 degrees, or the right triangle, is always opposite of the 2. The square root of 3 is always opposite from the angle 60, and the 1 is always opposite from the 30. In this case, we're dealing with an angle that's opposite of the side 1. So that means the angle that we're looking for, the reference angle, is 30 degrees, which is the same thing as pi over 6. So our reference angle here is pi over 6. Since neither of our triangles are in the first quadrant, we have to do a little bit of extra work to find the actual angle. To find the measure of the angle in quadrant 2, you can do pi minus pi over 6, which is 5 pi over 6. To find the measure of the angle in quadrant 3, you can do pi plus pi over 6, which is 7 pi over 6. So there are two solutions to the original equation on the interval 0 to 2 pi, and those two solutions are 5 pi over 6 and 7 pi over 6. To find all solutions to each of our solutions, we need to add 2 pi k, where k represents any integer. When we're using triangles to solve trig equations, it's helpful to write our answers as fractions. One thing that's going to help for this problem is to rewrite the answer as a fraction. So we've got tangent theta is equal to negative 1. This can be rewritten as negative 1 over 1, and therefore the numerator would represent the opposite, or y, value, and the denominator would represent the adjacent, or x, value. Since the value for tangent is negative, we need to identify the quadrants where tangent's negative, and tangent is negative in quadrant 2 and quadrant 4. The reason that tangent's negative in those two quadrants is that since tangent is defined as y over x, the result is negative if one of the values is positive and the other is negative. So in quadrant 2, that's where x is negative and y is positive. In quadrant 4, that's where the x value is positive and the y value is negative. And then we can try to draw our triangles. And when I'm drawing the triangles, I'm just keeping track of which value is negative based on the quadrant that it's in. You may notice that this is a special triangle. If you don't notice that yet, you can go ahead and apply the Pythagorean theorem to find the length of the hypotenuse, which in this case is square root of 2. And this is a special triangle for the 45, 45, 90 triangle, or in radians, that would be pi over 4, pi over 4, pi over 2 for the 90. Therefore, the reference angle that we're going to use to solve our equation is the reference angle of pi over 4 radians. Then to find the measure of the angle in quadrant 2, we can do pi minus pi over 4. Which is 3 pi over 4. And to find the measure of the angle in quadrant 4, we can do 2 pi minus pi over 4. Which is 7 pi over 4. These angles are both solutions to the original trig equation, and they fall on the interval between 0 and 2 pi. Now to find all solutions. To do this, we could use the same technique that we used in the other example, which is to, for each solution, add 2 pi k. However, with the tangent function, there's a more condensed way to express these solutions. And the reason that we can express a condensed form of the all solutions is the fact that the solutions, the angles, are all along the exact same line. And for this reason, if we have one solution, we can always find another solution by adding 180 degrees, or pi. So if we have an angle and if we add or subtract pi, we would always end up at another solution. So another way to express our answer in all solutions would be to pick one of the solutions. I'm going to pick 3 pi over 4, and instead of adding 2 pi, I'm going to add pi k, where k is an integer. This condensed expression also identifies all the solutions to this equation.